Hey everyone, thank you for checking out Mr. Ware's videos. And today we're looking at exponential functions. We're talking about exponential growth with rate, exponential decay with a rate like, hey, it grows by this much percent or it decays by this much percent. Here are the formulas and the notes for each letter here, what it represents. So definitely take notes, write this down, take a picture of it. Make sure you have this memorized. Over here on the right, these are some keywords to look for to let you know which formula you're going to use. Whether you're going to use the growth formula or whether you're going to use the decay formula. And if you take a look, the formula is exactly the same, except the growth has a plus and the decay has a minus. Makes sense, right? And you might see, instead of seeing T here, you might see X. Instead of seeing P here, you might see A, but they still the exact same thing. They represent the exact same thing. So what I'm going to do now is take a look at some examples and show you how to do some problems. Okay, so here we got a problem. It says the first charity week walk event had an attendance of 500. The attendance Y increased by 5% each year. Keyword, increase. So that's going to let us know we're going to use the growth formula. Plus, it also says what's the exponential growth function to represent this situation. So at first, we're going to write the function, and then we're going to plug in that input value, okay? So let's first write the function. We're going to start by using our growth formula, which is y is equal to a times 1 plus r raised to the t. So I use a here, same as p, but it's the exact same thing, okay? So we're going to find out these key things. The A is the initial value, and the rate is the percent. So we'll start with the A here. So the initial value is what you started with, 500. All right. Next, we're going to start with the rate, okay, which is just 5%, which I convert to a decimal, 0.05. Sometimes I put that 0 in front of the decimal, sometimes I don't. But here it's 0.05. Okay, and now if we write just the function, we're just going to put t here because that's going to be our input, because we don't know how many years it's going to be. Okay, we know it happens each year, but we don't know how many years. So this is the function. So all we need to know is how many years. We plug in the years and we can find the answer. Okay, so we got part A. Now we're going to do part B. It says how many people will attend in the 10th year. So from this is the initial 500. If it grows at a rate of 5%, how many people roughly will it be 10 years from now? Okay, so what we'll do is take that exact same formula, and since it says 10th year, we're going to plug in 10. So right there where the t is, we plug in 10. Same formula, same everything. And what we're going to do is just type in the calculator, like so. And since it says round to the nearest person, and this is 0.4 here, person would be a whole number. So that 4 is 4 less, so we round down. So it's going to be 814. All right, so that's all you got to do. You're just going to write the formula. Make sure you use the growth or decay. Make sure you get the right one. The key word here, increase, to let you know it's growth. And then you write the formula out and then plug in your values. All right, let's take a look at another example. All right, so the population of a small town was 3,600 in 2005. The population increased, keyword increased, by 4% annually. So we're going to use growth again, okay? So it says write the exponential growth function to represent this situation. So we're going to put in the function here. We got the same formula here. Y is equal to A times 1 plus R, which is a rate raised to the t time. All right, so we're going to put in our initial value, which is 3,600. We're going to put in our rate, which is just 4%, changed to a decimal. And then we're going to put t for time. So now we have our function. All right, next we're going to go ahead and solve it. Now, it says, what would the population be in 2025? round your answer to the nearest person. So I'm going to write the formula out here, and see, I left this spot blank because it doesn't tell me exactly how many years. It just tells me 2025. So we got to figure out from 2025, we started in 2005. So how many years has that been? So to figure that out, what I'm going to do is take the 2025 and subtract the 2005 and get 20 years. So it's 20 years of it increasing 4% annually. So then I put in my number 20 here for T. All right, and finally I'm going to go ahead and type in the calculator like so. And again, this is rounded to the nearest person. So this is 0.0. We're going to round down. 7,888. And that's it. That is using growth and decay formulas. Keep in mind, you want to look for those keywords. And if it's a decay word, use the minus and not the plus. Okay, but everything else stays the same. Okay, I want to thank you for checking out Mr. Ware's videos. Have a nice day.